Okay, so here we have a big old W kind of function, and they want us to just straight from the graph to write the equation for that thing. So this is getting kind of fancy. You're getting some pretty strong math skills at this point to be able to take a function like that and write the equation from the graph. So how can we do it? Well, we got to put together, you really have the skills, you've already got the skills. Let me show you. The first thing to do is notice the places it hits the x-axis. Those are called the zeros, the roots, or the x-intercepts, right? It goes by all three names. So take all the places it hits the x-axis, again, roots, zeros, or x-intercepts. And how does remember step one, you write y equals, there's going to be an a in the front, x, and then opposite. X, opposite. X, opposite, and x, opposite. You just keep putting the opposite of those places it hits the x-axis. Done this a couple times now, right? It's the same kind of thing. They're just helping us practice it more and more. So just take those places it hits the x-axis and put the opposite number in there. So I'm going to take that -3, put in +3. Take that -2, put in +2. Take that +1, put in -1. Take that +2, put in -2. So far, so good? Now we just have to find the A in the front, the number in the front. How do we find the number in the front? Remember what we do on the other ones? What do we use? Remember, there's one other point that we haven't used. Right there, yeah. That y-intercept point. Now, what's the coordinates for that point? Remember, because every dot has two numbers, really, right? What are his two numbers? 0, 4. Again, intercepts always have the other letter 0. So that means x is 0, y is 4. We just plug that in, and that'll let us find the A. So plug in, it's all right, plug in 0, 4. So the 4 goes in the the y spot, I mean. And the x spot is 0. Like that. And now we solve for A. So this would be A, 3 times 2 times 1, -1 times -2. That's A times 12. Last step to get A alone, divide by 12. And so how do we reduce 4/12? We divide top and bottom by 4, huh? So that's 1/3. So A is 1/3. So that's what A is. So our answer then, the function is 1/3, because remember A is in the front, 1/3 times x plus 3 times x plus 2 times x minus 1 times x minus 2. There it is. There is the function that produces that graph. That's pretty impressive, huh? We can work backwards from a pretty complex graph to the function producing that graph. Good there. Let's go to this one. Okay, now this one's a little different. I don't really care that it goes off the top up there. That's not my issue. My specific issue is the fact that it bounces here and it does a trick there. So up to now, now I need to give you a little bit of theory on the more advanced things that a graph can do. So, in fact, let's just go back here and let's lay it out real clear. So here's the game plan. Basically, it's all about what the graph does and what the power is. So if a graph passes through a point like this, so if it passes through, yeah, I don't like the way I'm doing that. Here, let's do that. Yeah, now I'm just muffing it up worse. Here, let's do a good job. Passes through. So if the graph just kind of like passes through like that, then that's just going to be, say it passes through at whatever, 3 or whatever. Then that's just going to be x minus 3 first power. Next, if the graph bounces at 3, then that's going to be x minus 3 squared. Do you see why they're both minus 3? Because it's opposite, huh? We always do the opposite. So opposite of plus 3 is minus 3 in the parentheses. But I want to show you it changes the power. So for a bouncer, it makes it a second power. Second power for the, and you know that, huh? You know a U-shape is a second power. That's what we spent last time working on. X squared graphs, U-shapes are second power, aren't they? No big surprise. If it bounces, it's a second power. If it's just a first power, if it passes through, and then there's a third, even more subtle case. And that is this. If you have the graph, and at 3, it does this. It does a shift like that. Do you see how that's a little different than those other things? That's a shift. What do I mean by shift? Well, it changed its concavity. As you go higher in calculus especially, you'll talk about concavity. That means bowl, like a bowl is got concavity to it. So see how this part is like a bowl turned up, and this part is like a bowl turned down? It shifted its concavity at that point. It was like a bowl up, and then it went to a bowl down. That kind of a shift, excuse me, that kind of a shift is a change in concavity. Let me draw it again. So it's coming down, and then it goes like that. So that's a shift in concavity. I'm not going to quiz you on that name or anything. But what that means is it's going to be third power. It's third power for a shift in concavity. See how, compare it to number 1, first case. See how up here on number 1, there was no shift of any kind, right? In the first case, it just went smoothly right on through that point. No shift of any kind. But on the third case, it was kind of going like this, and then it went like that. Do you see how it shifted concavity? Right? Like if you're riding on a roller, how about this? If you're riding on a roller coaster here, if you're riding on a roller coaster down there, you would pass through that, on that top graph, you would pass through that point and not even notice it. It's just smooth as butter right through there, right? But if you were on the roller coaster on this third graph going down, you would kind of hit that, you would think you're going to level out, and then it would take another dive. See how it like seems like it's going to level out and then takes another dive, a little shift. You'd feel a shift right there, wouldn't you? That's a third power. So a third power is a shift, second power is a U-shape, first power is a smooth right on through. That's multiplicity, remember? Multiplicity is the power. So that's what you have to recognize when you're working backwards from a graph to an equation. You got to put the right power on that x spot, that x-intercept, 0, or root, whatever you want to call it. All right, let's go back to it then. So with that in mind, on number 2, so let's try to write our function. It's going to be y equals a x. And remember, we put the opposite. In fact, let me move it down just a little bit here. Okay. So I'm going to put the opposite. So what is the opposite? So this x value, opposite, what am I going to put in the parentheses? Plus 2, right? And now you tell me what power, is that one a pass-through, a bounce, or a shift? It's bouncing. It's a U shape. So what power? 2. Squared, right. Squared or 2. No, you're right. Either way. Same thing. Squared or 2. Perfect. Good. And then the next one. X, going to do opposite. We're talking about this one right here. Oh, and we're going to do opposite. So what's going to go in the parentheses? -1. It's opposite of +1. And then what power? Is it a pass-through smoothly? A bounce, a U shape, or a shift? It's a shift. So what power? Third power. Third power. See, look back at the number 1. See how in number 1 they all just passed through smoothly? So that's why I didn't bother bringing this up. See, back at number 1, it's just smooth, 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 smooth. They're all just first power, first power. I didn't even show the powers. They were all just normal first power. We didn't mess with it. But on this number 2, they're being more fancy. It's shifting, it's bouncing. Okay, so that's step number 1. And you know step 2, right? What do we do on step 2? Okay. The y-intercept. So go ahead and do it. Same. So we finished exactly the same. Grab this y-intercept. Looks like 4. That's the point over 0, up 4. Plug that thing in and solve for A. Okay, so plug in 4 for y and 0 for x, huh? And so what do we get? 4 equals A, 2 squared, -1 cubed. 4 equals A, what is this? 4 times -1. 4 equals A times -4. Last step to get A alone. Divide by -4. A is -1. Is that good? So what's our final answer then? Taking this whole function, we've got -1. That's the A that goes in front. X plus 2 squared times x minus 1 cubed. There it is. There's the function. That's pretty impressive, huh? We can take a very fancy graph that does some very fancy stuff and work backwards to the equation for that graph. It's like I said, I showed you there's a lot of intercepts, huh? So how are we going to find the y-intercept? First thing they want, y-intercept. How do you find a y-intercept? You plug in x0. Remember, it means opposite letter 0. So go ahead, plug in x0. 0, 0, 0. And where's y? Right in the front, huh? Remember, function letters are y. So what will y equal? Yeah, 0 plus 0 minus 0 is just 0. Yeah. Good so far? Now step 2, find the x-intercepts. What do we always do whenever they ask us intercepts? Opposite letter 0, yeah. So if I want to find x-intercepts, I make y 0. Now where's y? Right in the front.
Thank you.
Right in the front. Like that. Is that good? Make sense so far? So this is what we've always done with intercepts, right? If you have an x-intercept, you make y 0. If you have a y-intercept, you make x 0. So we're looking for x-intercepts, so make y 0. So I plugged in y 0. And now I need to solve that equation somehow for x. Now this one is not as easy as those earlier ones we did. Do you know why? Because it's not in factored form. It's not the parentheses. Remember earlier we did these and we had parentheses and we could just look at them and go, oh, well, 2 and 3 or whatever, you know. So this one, you know what you need to do is you need to factor the right side. Remember how to factor? Yeah, what's the first step on factoring that right side? GCF, huh? GCF, yeah. What goes into all those? X. They all have X in common, huh? Right? And can you take it from there? Okay. So this is X squared plus X minus 6. Good so far? Right? Because if I was to multiply that X back through, it would work. And then the parentheses, X is in the front. What multiplies to be 6? What times what is 6? 3 times 2. 2 times 3. Either order doesn't matter. But the signs matter, huh? How do we do the signs? Remember that? Yeah, how'd you know? Yeah, because it's got to make plus 1, yeah. It's got to make plus 1, so plus on 3 and minus on the 2. Or yeah, I always told the rule the sign in the middle has to go on the bigger. Yeah, either way.
That'd be 3 answers, right? It'd be 0, -3, and +2.
Right, you're right, yeah. So we're good to there? So yeah, that's the next step. You're totally right. So we good to there? We factored it completely, right? Because plus 3 minus 2 makes plus 1 in the middle, and they multiply to be -6. Yeah, now, exactly. Like Faith was saying, now we just look at it, and we say, okay, we go, for every X, we ask ourselves, what could I plug in for that? Once you've got the parentheses, you can just do it by looking at it. So what could I plug into that first X to make it 0? Well, just 0, huh? Just straight on 0. What do I plug into that? That'll make that part 0. What do I plug in for X to make the next part 0? -3. And what do I plug in for X to make the last part 0? +2, -2. So the X-intercepts are 0, -3, and 2. Those are the X values that will make the whole thing, the Y, become 0. If you were graph it, those would be the 3 places it hits the X-axis. That's what that means. Is that good? Yeah. I'll do it with you. So as X goes to positive infinity, I'm just going to plug in positive 100. And I'm going to plug in right up here. So that's going to be 100 cubed plus 100 squared minus 6 times 100. Everybody good there? Really, you don't have to plug into all 3. Just the first one's going to matter. But I'll go ahead and show it formally. If you use your calculator, this one will be that many zeros. What is it? 1,000,000. It'll be 1,000,000. Plus, this will be 10,000, I think, minus 600. So 1,000,000 plus 10,000. Who's dominating there? Clearly the million. See how he just takes over? The most powerful term is so much more powerful. So where's this going? Well, where is Y going? Positive infinity, right? Not negative. The numbers get really, really big, really, really fast. And then the second question they follow up with is as X goes to negative infinity, I'll plug in negative 100. Again, I'm just going to plug into the front one. He's all that matters. The other guys are chump change compared to him. Negative 100, how, to the third power, it's going to be some gigantic number, but is it negative or positive? Negative. Because we have 3 negative signs, huh? Negative infinity. There we go. So quick with you. So for right-hand behavior, which way is X going? See? Positive. Yeah, here's the right. That's positive infinity. So positive or regular infinity. Well, which way is the function going? As we go to the right forever, the function is going, yeah, down. Okay, now how about to the left? For the left hand, we're going this way to the left, which is negative infinity on the x-axis. And how's the function? The y values, what are they doing? It's going up, 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 and away to positive infinity. Just like that. All right, easy. All right, how about that? Back to this least possible degree. They're kind of reviewing some of the stuff in the last section. What is the least possible degree points does that graph have? Just right here, huh? This is his only where he goes from going up to going down. He changes his direction there, his turning point. So if you just have, so the degree is equal to the turning points plus 1, isn't it? So 2. 1 plus 1, 2. The degree must be 2. And you know that, huh? It's a U shape. We could have just said it's a U shape. It's got to be x squared. It's got to be degree 2. Yeah. That's the least it could be. It might be part of a x to the 10th fancy thing, but at least it's x squared or bigger. That's what we're saying. All right. Number 6, that's a little more fancy. Try that one. Same thing. Okay, number 6. Here it is. How many turning points? 2. I'm just thinking 3. Oh, you're doing the final question. Yeah. So the number of turning points is 3. So the degree, which is turning points plus 1, must be 3 plus 1. So the degree has to be at least 4, doesn't it? To have that many turning points. It's degree 4 or more. Yeah. Good, easy. If you have that on your 3x5 card or you just remember it. All right, on we go. Number 7. Now, this is good. Now they're having us look at the graph and identify the roots and what their multiplicity is. So they want us to go one by one, like they're starting here with the root x equals -4. That's this point right here, huh? And they're asking us, remember the rule still on the board? Remember the rule we learned about what the power must be there? Multiplicity is a fancy word for power because it means how many times something's multiplied, right? That's what a power does on something. Like if I go 7 to the 3rd power, that means 7 multiplied 3 times, doesn't it? So a power is a multiplicity. So what is the multiplicity for this guy? Does this one pass through, bounce, or shift? Passes through. So what's his multiplicity? 1. Got to be. All right. What's the next root? Right there. And what's that? 0, huh? Yeah, the next root is 0. Oh, wait. Hold on. I'm doing this wrong. They're saying multiplicity 1. That 0 doesn't have multiplicity 1, does it? Because it's a bounce, but you can tell it looks like a U shape right there. It's x squared. So they must want me to put the other one on that line. I thought they went in order. I guess they don't. So what they must want me to put this one, because this one has multiplicity 1, right? Multiplicity 1, multiplicity 1. This one here has multiplicity 2. So they must want me to put the 4 there with multiplicity 1 and the 0 here with multiplicity 2. Yeah, they're being tricky. They're putting them out of order. The multiplicity is 2 because whenever they bounce, the power is 2.
Oh, okay.
Yeah, so whenever it bounces, see how it's bouncing right there at 0? Comes up and it bounces. Whenever it bounces, that's a second power. That's an x squared. That's a little piece of an x squared graph, isn't it? So that's
So
multiplicity
there could
2.
be multiple either pass through, bounce, or shift in one graph?
Yeah,
Okay.
yeah, they can mix them all in there. That's right. Good on that one? Let me know. All right, I think these will be super easy for you. So, number 8. Yeah. So here we are again, exactly, doing that same thing we were doing before with roots or zeros, whatever they want to call them. You just take these numbers in the parentheses, and we do exactly what Shantina's saying. We do opposite, 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 don't we? So it's going to be +5, -1, and positive or regular 2. Is that good so far? You just opposite. Whenever they're in the parentheses, it's just opposite. And then what are their multiplicities? Yeah. It's just the fancy word for those powers. 9, 8, and what's the last one?
1.
Yeah, it's visible. 1. 9, 8, and 1 are their multiplicities. Can you do the next 2? Oh, the number 10 will be a little tricky. Yeah, try the next 2. So here, we'll do this one. So opposite, opposite, opposite. So 1, -6, 5. And the powers, the multiplicities, 7, 6, and 1, huh? But then number 10 is a little more tricky. So the first one is normal enough. You know, we do opposite of -4 is 4. And but how are we going to do opposite of that? Well, here's what you have to actually do. Really, we're finding out what makes these 0. right? Right, think with me. When I say, another way you could think about opposite, like when I look at this guy, what am I gonna say this one is? It's gonna be 5, huh? Because it's opposite of -5. Well, do you realize 5 minus 5, that's what makes it 0. So that's another, whenever somebody says to you, oh, you're finding the opposite, another way you could say that is you're finding what makes it 0. Is that sentence making sense? Right? Whenever you're finding the opposite of something, really you're finding what makes it 0, right? So what you could do then on a harder one like this is just take it out of its little parentheses, minus 12n plus 7, and just set it equal to 0 and just solve the equation, because that's what you're really trying to find. The other ones are so easy we can just look at them, so I didn't do this formal thing. But this one's a little harder, so let's actually do the formal step. Just take it out, set it equal to 0, because we're trying. That's what opposite means. Finding out what will make it become 0. So can you solve that little equation real quick? So what do I do to solve for n? Subtract 7, right? You guys know how to solve equations real well. Good. Minus 12n is minus 7. Last step. Divide by the minus 12. And so what is n equal? Negative or positive? Yeah, because it's 2 negatives, huh? So positive 7/12. So positive 7/12. That's the opposite. So opposite really means equal to 0. Make it equal to 0. And then what about the third one? Opposite of the third one? Just 5, because that's what makes it 0. And the multiplicities, the powers, 1 for the first one, and then 3, and then 4. So they're giving us zeros and multiplicity, and they want you to write a function. So can you go ahead and write the function on that? Remember how we learned to do the parentheses, the y equals parenthesis x, and always putting the opposites in there, like that. All right, we good? So it's opposite of minus 1, plus 1 in the first power, right? Opposite of, what is that, plus 6? Yeah, 6. So it'd be minus 6, first power. Opposite of minus 4, plus 4, first power. And there it is. And really, you don't even have to show those 1 powers, do you? In reality, you would just go x plus 1, x minus 6, x plus 4. How about number 12? Can you do that one? I'll just jump in there. I think that one's easy for you. So that one's going to be x with the opposite every time. Opposite. So that will be 0, so x minus 0, or plus 0, it doesn't matter. Really, this is just going to become x, isn't it? Because x minus 0 plus 0, whatever. Yeah, it's just 0. That's right. Just like Dalton was saying, it doesn't matter. It's just x either way. And then this will be x plus 4. This will be x minus 7. Now this one has a second power, third power, third power. So it'll be x squared, x plus 4 cubed, x minus 7 cubed. There it is.